students, in today's video we are gonna do find derivatives by first principle method, exercise 2.2 of chapter number 2 from second year mathematics book. You all know that we have done derivatives by first principle method in our previous exercise 2.1 last two questions, but the method was different because those questions include under root means the power of a variables 1 by 2. That method was a bit different, but this method is a bit different. So keep in mind that if you have questions including under root, then you can follow that method. But if you did not have this under root in your question, then you have to follow this method, which includes that method includes rationalization, and this method includes binomial theorem. We have to apply binomial theorem in this method. So we are going to solve question number 1, which is question number 1 part 1, which is ax plus b whole power 3. So first of all, what we have to do, we have to follow all the steps which we have done earlier for solving by definition, derivatives by definition. So we solve it as, first of all, we let y is equal to ax plus b whole power 3. Then what it's step number 2 is we have to add a minor change, which is partial y on left hand side and partial x on right hand side in the term x plus partial x plus b whole power 3. So it becomes, we can simplify it as ax plus b, we can write it as like this also, plus a partial x. By multiplying a inside, we get ax plus a partial x plus b whole power 3. Okay, so we can write this expression as ax plus b plus a partial x whole power 3. Okay, now what we are going to do is we are going to apply binomial theorem on this, which is, binomial theorem is, I'll show you what is binomial theorem. It is a plus b whole power n. It becomes a power n plus n into a power n minus 1 b plus n into n minus 1 divided by 2 factorial a power n minus 2 into b square. Gradually, as the power of a decreases by minus 1, the power of b increases by 1. Okay, at last we get b power a simple. Okay, the power of a also decreases, that's why a b power n. Okay, we get, sorry, only b power, not a, b power n, we get this part. Then this is known as binomial theorem. We are going to apply this theorem here. It becomes y plus partial y is equal to, here we have ax plus b as a factor number 1 and a partial x as a factor number 2. Means a is a factor 1 and b is factor 2. So we are going to apply this here, ax plus b whole power, here n is equal to 3, so we can write it 3 here, plus 3 into ax plus b power 3 minus 1, which is 2, into a partial x, which is our factor number 2. Okay, plus 3 into 3 minus 1 divided by 2 factorial into ax plus b power 1 a partial x power 2. Okay, we have to add some other factors. The remaining factors we're going to write here, plus, what's this? Yes, it becomes 3 into 3 minus 1 3 minus 2 divided by 3 factorial into a partial x power 3. As we know that it becomes like, by subtracting this minus 1 in this factor, we get like ax plus b power 1 minus 1, which becomes equal to 0. This is 0. So as we know that the power of any factor equals to 0 becomes equal to 1. So here it can be multiplied by 1, so it doesn't affect, right? We can write it or do not write it. It all depends on us. Okay, so we are solving it properly by solving it, simplifying of the binomial theorem. We have n equal to 3, so it becomes this. Now again, simplifying further, we get ax plus b power 3 plus 3 into ax plus b whole square a partial x. You can note that y, the power of, power, it's not the power, but the question was ax plus b whole power 3, means that what we supposed y is equal to ax plus b whole power 3. So we can write this factor also as equals to y. Okay, this factor is equal to y, so we can write it as y also. Plus, here we get 3 multiplied by 2. The factorial of 2 is equal to 2. The factorial of 2 is equal to 2 into ax plus b into a partial x whole square. The power 1 we can write it or not, it doesn't matter because we have written the factor as well, plus 3 into 2 into 3 minus 2, 1. So you can note it that the 3 factorial can also be written as 3.2.1. This factor is also a 3 factorial. So we can cut them. We can cut this 2 by this 2, this 3 factorial, but this means that this whole factor is cutted. So the remaining one is coefficient is 1. Okay. Into a partial x power 3 is equal to this y factor. We can write as this, like partial y is equal to, we can subtract our fourth means third, like third, yes, third. Our third step is to subtract y from both sides. We are going to subtract y from both sides, so it becomes only minus partial y, because the y is subtracting. So y plus 3 into ax plus b whole square into a partial x plus 3 into ax plus b a partial x whole square plus a partial x cube minus y. So this y is cancelled by this y. The remaining our part is 3 into ax plus b whole square a partial x plus 3 into ax plus b into a partial x whole square plus a partial x whole cube. We are gonna taking common a partial x, because you can note that all the factors are including a partial x, right? So we can take it as common a partial x, 3 into ax plus b whole square plus 3 into ax plus b into a partial x plus a partial x whole square. These are the remaining factors. Now our fourth step is to divide both sides by partial x, right? The third step is subtract y from both sides. Okay, so what we are going to do, dividing these factors sides by partial x, partial y by partial x is equal to a partial x divided by partial x into 3 ax plus b whole square plus 3 ax plus b into a partial x plus a partial x whole square. But partial x is cancelled by this partial x, so our remaining factor is partial y divided by partial x is equal to a into 3ax plus b whole square plus 3 into ax plus b into a partial x plus a partial x whole square. Now what we are going to do, our last step is to take limit. So our final step number 5 is taking limit. So we take limit partial x approaches to 0 on both sides. So it becomes limit partial x approaches to 0, partial y divided by partial x is equal to limit partial x approaches to 0. Our factor is, so this is our factor. So we are going to applying the limit partial x approaches to 0. You know that all the factors I have told you earlier in all of the examples or questions we have done for derivatives, like by definition, I told you that while taking limit partial x approaches to 0, all the factors including partial x becomes approaches to 0, means that we can write or we can doesn't, if it depends on us. So we do not write all the factors partial x approaches to 0, means that including partial x. So it becomes approaches to 0, this one also approaches to 0, so we are not going to write them. This side becomes dy divided by dx is equal to a into 3 ax plus b whole square. This factor includes partial x, so it becomes 0. This also includes partial x, so it also becomes 0. Our remaining answer is 3a into ax plus b whole square, which is our required derivative by first principle method. So I hope so you understand that how can we find derivatives by first principle method. Now for your convenience, I'm doing question number 2. It means that I'm doing all of the exercise for you. So our part number 2 is 2x plus 3 whole power 5. This is our question. This is our question. Here the power means n is equal to 5, right? First of all, we are going to apply all steps, follow our steps for definition. Number step was, one was is equal to, y is equal to, we let 2x plus 3 whole power 5. Then number 2 was y plus partial y is equal to 2 into x plus partial x plus 3 whole power 5. Now we simplify this by multiplying 2 inside. 2x plus 2 partial x plus 3 whole power 5. It becomes 2x plus 3 plus 2 partial x whole power 5. Now we are going to applying binomial theorem. We can write it as apply binomial theorem. We get this factor equals to 2x plus 3 whole power 5 plus 5 into 2x plus 3 whole power 5 minus 1 equals to 4 into 2 partial x plus 5 into 2x plus, sorry, it's not 5 into this thing. We have to write the other factors too, like 5 into 5 minus 4 divided by 2 factorial, 2x plus 3, and then power 3. 4 minus 1 is equal to 3, then 2 partial x power 2 plus 5 into 5 minus 1, 5 minus 2 divided by 3 factorial, it's 1, sorry, into 2x plus 3 whole power 2 into 2 partial x whole power 3, right? Plus 5 into 5 minus 1, 5 minus 2, 5 minus 3 divided by, so it's 4 factorial, 4 factorial 2x plus 3 whole power 1 into 2 partial x whole power 4 plus 5 into 5 minus 1, 5 minus 2, 5 minus 3, 5 minus 4 divided by 5 factorial. This one equals to the 5 factorial also, so we can cancel both of them. Means it becomes 4, it becomes 3, it becomes 2, it becomes 1. So it becomes 5 factorial, which is equal to 5 factorial. So this cancels this 5 factorial, it becomes 1 equals to 1. Okay. Sorry, it was not recorded, but it becomes, hope so you understand. 5 minus 1 is equal to 4, 5 minus 2 equals to 3, 5 minus 3 is equal to 2, 5 minus 4 is equal to 1. So it becomes 5 factorial equals to. So 5 factorial cancels this 5 factorial values, and it becomes equal to 1. Okay. Our factor is 2 partial x whole power 5. Now simplifying this, we get equals to 2x plus 3 whole power 5 plus 5 into 2x plus 3 whole power 4 into 2 partial x plus 5, it was 5 minus 1, 5 into 4 divided by 2 factorial, 5 multiplied by 4 divided by 2 factorial into 2x plus 3, 2 partial x whole square plus 5 into 4 into 3 divided by 3 factorial into 2x plus 3 whole square, 2 partial x whole cube plus this is 5 minus 4, 5 dot 4 dot 3 dot 2 divided by 4 factorial into 2x plus 3 into 2 partial x whole power 4 plus 2 partial x whole power 5. Okay. Now further simplifying, we get plus 2x plus 3 whole power 5 plus 5 into 2x plus 3 whole power 4, 2 partial x plus, it becomes 5 into 4, means that it becomes 10. 2x plus 3. You can use calculators to solve these values, but it's simple, very easy. You can solve it as 5 multiplied by 4 divided by 2 factorial. So 2 factorial is equal to 2 multiplied by 1 is equal to 2 factorial, sorry, 2 factorial. So here you can see that 5 multiplied by 4 equals to 5 multiplied by 2 multiplied by 2 multiplied by 1. So we can write it as 10 multiplied by 2 factorial. So dividing by 2 factorial, it cancels this like this. So we get 10 here. Here we have 3. 4 divides into 2 multiplied by 2, so it becomes 3 multiplied by 2 dot 1. So 3, it cancels by this, so remaining is 5 multiplied by 2, which is 10. Here we have 4 dot 3 dot 2 dot 1, doesn't matter, so it becomes 4 factorial. 5 multiplied by 4 factorial, 4 factorial cancels this, so we get the remaining is 5. Okay. 2x plus 3 into 2 partial x whole square plus 10 into 2x plus 3 whole square, 2 partial x whole power 3 plus 5 into 2x plus 3, 2 partial x whole power 4 plus 2 partial x whole power 5. Now we have to do what? From here you can see that y plus partial y is equal to this thing. The further step is to do subtracting y from both sides. So this factor y is cancelled. This factor, you know, that is also equals to, you have to read the question, which is also equals to y. This is equal to y. So I'm excluding a step by from here just because it's gonna too lengthy. So we can write as y. This y can also be cancelled by this. So if we can subtract or by cancelling it, it is same. So this factor is excluded from here by following our step that we have to subtract y from both sides. So our remaining factor is this. We are going to write this on our next page, which is equal to 5 into 2x plus 3 whole power 4, 2 partial x plus 10 into 2x plus 3, 2 partial x whole square plus 10 into 2x plus 3 whole power, sorry, here we can write 3. So this is 2 partial x whole power 3 plus, sorry, here is 5. So here we have written off all of your values. You can see that all these values or factors includes partial x, 2 partial x. So I'm going to take in partial x, 2 partial x common. Here 2 partial x, 5 into 2x plus 3 whole power 4 plus 10 into 2x plus 3 whole power 3, 2 partial x plus 10 into 2x plus 3 whole square, 2 partial x whole square plus 5 into 2x plus 3 into 2 partial x power 3 plus 2 partial x power 4. So our next step is to divide both sides by partial x. So we get partial y divided by partial x is equal to, we can also do that, this partial x multiplies here, we can bring this partial x on this side, it becomes partial y by partial x, so it's same, both methods are same. So I can write as 2 into partial x, but for your convenience I'm doing the same process so it does not becomes difficult for you. 2x plus 3 whole power 4 plus 10 into 2x plus 3 whole power 3 into 2 partial x plus 10 into 2x plus 3 whole square into 2 partial x whole square plus 5 into 2x plus 3 2 partial x whole cube plus 2 partial x whole power 4. This partial x cancels by this partial x, so it becomes 2 into 5 2x plus 3 whole power 4 plus 10 into 2x plus 3 whole power cube into 2 partial x plus so on plus 2 partial x whole power 4. Our fifth and last step is to take limit. Take limit partial x approaches to 0, so it becomes limit partial x approaches to 0 partial y divided by partial x is equal to limit partial x approaches to 0 2 into 5 2x plus 3 whole power 4 plus 10 into 2x plus 3 whole cube plus so on plus 2 partial x whole power 4. I am not writing the central factors because we know that all these factors include partial x, and we also know that the factors including partial x while taking limit becomes 0. Okay, so all the factors including partial x becomes 0. That's why I'm not writing them here. This one plus it becomes dy by dx is equal to 2 into 5 2x plus 3 whole power 4 plus, sorry, the remaining is 0. So we get, simplifying by simplifying, it becomes 2x plus 3 whole power 4 dy by dx. This is our required derivative by first principle method. Okay, I hope so you understand better now, but for your convenience I'm going to do our question that includes negative or division, that is written in division. So let's do that. We have question number 3, which is 3t plus 2 powers minus 2, means that it is equal to 1 divided by 3t plus 2 whole powers 2, right? Here 2 is positive integer. So this question means that in this question we have the only independent variable, which is t. So don't be worried about that. There is written z, like in question number 5 we have, in question number 5 we have 1 divided by az minus b whole power 7. So here we have z as an independent variable, so we have to solve this question as, like, you have to write y is equal to f of z, right? If you have here t or p, like anything, you have to write like, it's like, if for t it is f of t y is equal to, and for p it is y is equal to f of p, right? And you have to make increment, means like we have done earlier, y plus partial y is equal to x plus partial x. So here we are gonna do, like in this question we have to do y plus partial y is equal to f of z plus partial z. So means that where there is written z, you have to write z plus partial z. And for t, like in this question, I'll tell you that how to solve this, right? Don't be worry about that. There is written t or z or anything else other, but you know that this is a very independent variable, then you are going to solve your question in that way, the same way. Okay, don't forget the procedure, just follow the steps, you'll get the right answer. Okay, this is equal to this, so I'm going to add minor change, which is, first of all, we let y is equal to 1 divided by 3t plus 2 whole square. Then what would we do is, like t plus 2, then we add a minor change, y plus partial y is equal to 1 divided by 3 into t plus partial t plus 2 whole square, right? Now we simplify this as we have done for all our earlier questions, like 3t plus 3 partial t plus 2 whole power 2. It becomes 1 divided by 3t plus 2 plus 3 partial t whole power 2. Okay. Now we do our step number 3, which is subtract y from both sides. Subtract y from both sides. So we get partial y is equal to 1 divided by 3t plus 2 plus 3 partial t whole square minus 1 divided by 3t plus 2 whole square. Right, now we simplify this factor, right? It becomes 3t plus 2 plus 3 partial t whole square into 3t plus 2 whole square, and it becomes 3t plus 2 whole square minus 3t plus 2 plus 3 partial t whole square. Okay, so we are going to solve its numerator by solving it by using binomial theorem. So we can write, using binomial theorem, its numerator becomes, means you can write 3t plus 2 whole square minus 3t plus 2 plus 3 partial t whole square is equal to, this factor will remain same, we are not gonna do any change in this, whole square minus this factor becomes 3t plus 2 whole square plus 2 into 3t plus 2 into 3 partial t plus 2 into 2 minus 1 divided by 2 factorial into 3 partial t whole square. So it becomes equals to 3t plus 2 whole square minus 3t plus 2 whole square plus 2 into 3t plus 2 into 3 partial t plus this is also equals to, we know earlier that 2 minus 1 is equal to 1 and 2 multiplied by 1 equals to 2 factorial. So this is also 2 factorial, it cancels and becomes only 1. So we write it or do not write it, it doesn't matter. So it becomes 3 partial t whole square. Okay, these both are same, so this becomes 0. This is equal to, becomes equals to 2 into 3t plus 2 3 partial t plus 3 partial t whole square. We are gonna taking common 3 partial t, 2 into 3t plus 2 plus 3 partial t. Now our fourth step is divide by partial t, right, on both sides. Divide by partial t on both sides, we get partial y by partial t is equal to, this t cancels by that partial t, so it becomes 3, remaining factor is 3 into 2, this is what? This is partial y. So partial y by partial t is equal to 3 into 2, 3t plus 2 plus 3 partial t, this. Okay, see here that this, we are naming this equation by 1, and now we put this value in equation and dividing, placing value in equation number 1 and dividing it by partial t becomes.
Now we take limit partial t approaches to 0. It becomes limit partial t approaches to 0, partial over partial t equals to limit partial t approaches to 0. 3 into 2, 3t plus 2 plus 3 partial t divided by 3t plus 2 plus 3 partial t whole square plus 3t plus 2 square. Now it becomes, as we know that all the factors including 3 partial t becomes 0, so we write the remaining ones is, it becomes like this. We get 6 into 3t plus 2 divided by 3t plus 2 whole square, 3t plus 2 whole square. Yeah, we write square on both sides. It's square, yes. It becomes 6 into, now we, as we know that the factors are same, so we add the powers, 3t plus 2, 2 plus 2, and the upper power becomes minus 1, that's why it becomes like this. 6 divided by 3t plus 2 whole power 3, dy by dx is equal to 6 divided by 3t plus 2 whole cube is equal to 6 into 3t plus 2 minus 3 power, which is equal to our derivative. Now for required derivative,